morning to all of you. Myself, Dr. Jaishree Jain, Associate Professor from Ajay Kumar Engineering College, Ghaziabad. So today we will learn in this lecture about the Bayesian learning. This is the topic in machine learning techniques. So we have to learn what is this machine learning algorithm and how it works. So firstly, we should know this is in part of Unit 2 Bayesian learning. So this type of learning actually is a supervised based learning in which we have the labeled data set. So this algorithm is based on probabilistic model. So it has a probabilistic approach, and as we know, we have already aware with the conditional probability of the event. So this model actually predict according to the if we have any data set x1, x2, x3, and we have the output y, then this data is already labeled. Then we have to just find out the occurrence of these features. If these are the important feature, then we include all and find the occurrence if these three events are true. So we have to just use the Bayes theorem, and for calculating this, for learning this approach, we have to know about what is Bayes theorem, because it uses the approach of Bayes theorem. So it is a Bayesian reasoning provide the basis for learning algorithm that directly manipulate on the probabilities. So we can say firstly Bayesian algorithm that calculate the explicit probability, and it provide the useful perspective for understanding. So we just understand what is Bayes theorem. So what is the features of Bayesian learning method? So we have to observe the training example I already told, and we can just calculate the probability of each and every feature have to be occur, or it should be consistent with the possible class. If we have two class in at y label, we have two class, yes or no. So we have to check whether these feature x1 and x2, the value of these feature will belong to yes class or no class. So we will calculate the probability of each feature with respect to the label. So here we have to just make the hypothesis. Hypothesis means we have to check the condition whether H1 means we have here feature x1 value and x2 value, and whether it belong to yes class, then this hypothesis belong to yes class. So yeah, hypothesis means we are going to make the condition which is consistent with the respective class. So in Bayesian learning, what we have actually given in the data, we have prior probability of each candidate hypothesis. It means candidate means we have hypothesis for yes class, and we have hypothesis that belong to no class. Hypothesis means we have here the feature value, means if weather is sunny and temperature is warm, then we can say that Tom will go outside for play. So there are the feature like sunny and warm. So we can include the feature value and can get the consistent hypothesis. So we have to calculate, it will be given the probability of class sunny, value sunny that belong to yes, and we have to calculate the probability of sunny that belongs to no. So it is the approach actually. So we have to this will be given the prior probability and probability distribution observed data for each hypothesis. So we will calculate how it will be calculated. The formula for calculating this is, we required the initial knowledge of many probability in this case, and significant computational cost will be required, because while calculating probability, we have to calculate apply the mathematical formula here that will create some cost. So calculate the probability of hypothesis based on prior probability and probability of observing various data in the hypothesis. Means observed data means what is the data set P of D of for each given data set. So we can say we have initial hypothesis, initial probability of each hypothesis. This is called as prior probability, and P of D is the entire observed data probability, and we have to calculate this one. This is called as the likelihood. We have to calculate this or it should be given for entire data set how much hypotheses are true, and what is the probability. And because these all are the joint probability, so we will divide it. If we are calculating P D given H, it is the symbol of given, then we have split it P xi or x1 given H into P x2 given H. So we, in entire data, how much feature are there, we have to calculate each and every data probability, and this is called as the posterior probability, in which we have to check the those hypotheses which are actually true with respect to that data set. So that hypothesis will be fetched from here, which have the maximum probability the data will belong to that class actually. Or for unseen data, we can predict which hypothesis have the maximum probability with respect to that feature value. So this is the Bayes theorem, in which we will calculate the hypothesis probability and will find the result for unseen data also. So this is the formula P H given D, we have to compute. This is called as posterior probability, and this is called as a likelihood, and this is the prior probability, and this is marginal. So these all are the values belong to in this formula. So we can say what is maximum of posterior hypothesis. So we have to find the maximal probable hypothesis, because we have multiple hypotheses in our data set. So how can we find the maximum of posterior hypothesis, in which hypothesis have the maximum probability. So this is a formula for calculating the maximum of posterior hypothesis. Argmass H belong to H, means all hypotheses belong to these set, and P H given D means posterior probability of hypothesis with respect to data set, and for in which we place this formula here. This is the formula for Bayes theorem, and after that this denominator we have to obsolete actually for calculating the maximum of posterior hypothesis, because we are not performing the actual value, we are not calculating the final value, we only find the maximum hypothesis, probability of maximum hypothesis. So this denominator can be obsolete. So we will assume that every hypothesis H is equally probable, having the probability P of Hi equal to P of Hj. So we assume all hypotheses have the equal probability. So this probability will get 1, and we can obsolete this. So we further simplify this equation. H of maximum likelihood. Maximum likelihood, this is already I told, this is likelihood. So we can calculate only this also. So we can find the maximum likelihood having. So we can find the hypothesis which have the maximum likelihood actually. So which hypothesis have maximum likelihood, that belong to the maximum probability as well. So this is the formula which is called as a maximum likelihood hypothesis. Fine. So to illustrate the Bayes rule, actually we can consider one example here. With the example we can understand. So if the patient has particular form of cancer and patient does not have the particular form of cancer, this is our hypothesis, whether patient have the cancer or whether patient have not cancer. And what is the condition? There are two conditions. If we calculate, if we find the symptom, or we just have the lab test, one report is positive and one report is negative, and the prior knowledge is given entire population of people having 0.008 have the disease, means cancer probability of having cancer is 0.008. So not cancer will be 0.992, right? This is prior knowledge given, and for a lab test it is given that correct if the report is positive, then 98% chances of cancer, and if the report is negative, only 97% that disease is not present. So we can formulate this. P of cancer is 0.08, not cancer 0.992, and if it is having positive result, then probability of cancer is 0.98. So not cancer is 0.02 here, and for positive not cancer is 0.03, because 97% of not cancer. So it is given already. So what we have to calculate, we have to apply the, we have to find the maximum of posterior hypothesis here with having this formula. So we apply this, first case is positive given that cancer into P of cancer. So this will multiply and we will get this value, and then positive with not cancer and P of not cancer. So we will find this value. So high probability value is for negative. It means lab test is getting the false result, because if patient have positive result, then the probability of not cancer is highest, means patient has not having no cancer if the result is positive. Fine. So this is the result, and here we can apply the maximum a posterior hypothesis. So what is the relationship between concept learning and Bayes theorem? Actually, in previous topic we have learned about the concept learning. So in concept learning we already learned we have just to generalize, because there are certain hypotheses H1, H2, H3. So we just find the specific or generalized hypothesis. So here we mark the question mark according to the number of data features. So if we have 6 feature or 5 feature, then there will be 6 question mark. This is the generalized hypothesis. And when we get the consistent hypothesis, then we can replace here sunny or warm, for which these value is consistent with the yes class actually, and remaining value will remain the question mark. This is one data set, this is one example actually I am taking here. So it only can generalize well to predict the unseen data, but in case of Bayes theorem, posterior probability that can be used for the basis for straightforward learning algorithm, that is calculate the probability for each possible hypothesis and output the most probable hypothesis. So these are the basic probabilities formula. So if we have two event A and B, and both event are actually independent, so we can calculate the P A and B, that is P A given B into P B, or P B given A into P of A. Fine. So some rule is when we have disjunction, means two events are correlated with each other, so then we calculate A or B, means both are equally important. Then we have PA plus PB minus PA intersection B, and this posterior probability we already learned. And if we have number of event A1 to AN mutually exclusive, then we can make the summation, and all the sum of all probability will get the value 1. So P of B is PB given AI into P of AI. PB will be PB given A into PA. So we can calculate the total probability here. So what is optimal classifier here? So we can take the example, what is optimality actually? We have number of hypotheses, we have calculate maximum probability, but now what is the formula for optimal classifier? So if we have, we can take the example, we have 3 hypotheses H1, H2 and H3. H1 have the 0.4 value, and this probability is 0.3, 0.3. So we can, for a new instance X, we have to classify whether it will belong to positive class, well, means positive hypothesis, and whether it will belong to negative hypothesis. So we can calculate it with the help of this formula. So actually we divide this formula, actually we have number of attribute Xi and we have number of classes Ci. So this is the likelihood actually. So we can calculate here with the help of P of, I can for actually changing this formula like this, Vj is the class actually. So class is Ci, there can be 2 class, C1 is for positive, C2 is for negative. So we Ci, and given that entire data D, so we can split it. It will be equal to P of, means we can reverse it, P of Ci given that Xi or hypothesis Hi into P of Hi for entire data set D. So what we are calculating here, the maximum likelihood. So maximum likelihood can be splitted. This is the maximum likelihood formula we already learned. We can split it with the help of this hypothesis. So what will be the output? So we have first hypothesis H1 on the entire data set, which having the probability 0.4, and this is for positive class. So P positive given H1 will be 1 and P negative for H1 will be 0. This is already given actually. For H2 hypothesis, this is belong to negative class. So we have this probability for entire data, probability is 0.3, and for negative class of this hypothesis it has 1, and for positive it will be 0. Similarly for here, because H2 and H3 belong to negative class and V is positive and negative, this is the class. V is nothing, V is class. So we can use here C or V, we can here place the Ci or Hi. We have splitted this maximum likelihood into P of Hi given entire data. So include, this is Ci given D, which we have divided into two parts. This is chain rule actually. So we can place here the positive, for positive class P Hi and P of Hi given D. First is this. So this probability is 1 into 0.4, this is 0.4, and this is 1 into 0.6 because there are two hypotheses, H2 and H3 having 0.3 plus 0.3. So 0.6 into 1. So what is the case? This is the negative, highest probability is for negative class. It means the new instance X will belong to the negative class. Fine. So this is the example here. So we have calculated this. This is the that maximize the probability of new class that is classified correctly. So this is called as a Bayes optimal classifier. Bayes optimal classifier. So here we can take the another example as well. We have data set x1 up to xn and we have class y. So I already here written Ci. This is y actually class. And for entire data is divided. The entire data will be divided into feature x1, x2, x3. So we can take opposite here, P of x1 given y into x2 given y up to xn given y into P of y and divide by P of x1 up to xn. This is Bayes theorem actually. So we can combine here, integrate P y into projection of I is equal to 1 to n P of xi given y upon P of x1, x2 up to xn. So this will be the formula. So here we can take one example. We are taking two feature here, outlook and temperature. So for outlook, what are the yes case, and for temperature, what are the yes case, and for outlook, what are the no case, and temperature, what are the no case. So here we can first take the variable outlook. Here we have sunny, overcast and rainy. Three values here. Yes case for sunny is 2, no case are 3. So here we can see for sunny yes case, no case are this 2, and for sunny this is also no case for 3 no case, and here we get yes and here we get yes. So we have two values for yes. So 2, 3 means out of 14 instances we have 9 yes, total 9 yes are there, and total for no case we have only 5. So 2 by 9 and 3 by 5. 4 by 9, 0 by 5. 3 by 9, 2 by 5. So this is the for first attribute, and for second attribute hot, mild and cold. 2 by 9, 2 by 5, yes or no. 4 by 9, 2 by 5. This will be the probability. Next we will just combine it for sunny and hot. So total yes will be for sunny and hot. Total yes will be 2 is for yes and hot 2 means 4. So we have to calculate the probability of this. So total yes will be 9 by 14, total no 5 by 14. We have to calculate this for yes, sunny and hot. So it will contain the probability of sunny with yes into hot with yes into P of yes. So sunny with yes is 2 by 9 and hot with yes is also 2 by 9 and total yes is 9 by 14. So we will get this probability here, and similarly for negative class we will have sunny with no, hot with no and P of no. So we will get this probability. We will add this 0.27. So divide this one for yes class 0.031 divide by 0.27. Total probability we will get the value 0.114. And for negative class 0.0857 upon 0.27. So which probability is higher? This is for no. So probability of no is more means player will not enjoy sport event. Fine. So thank you so much.